Good day everyone, we're back again with another task. Remember that this is laboratory activity number 5 and our group selected potato for this experiment in which we will see how a potato browns in various pH solutions. If you've ever created a potato dish, you've probably experienced amazing success and failure with the same recipe. In some situations, the fries are great, while in others, they brown too quickly and burn. Most likely, your recipe is good but you're using a different sort of potato or potatoes that have been stored differently. A potato softens and changes texture in some cooking methods, but it also turns brown. Just imagine fries or chips. This change can only be found in preparation procedures that use high temperatures and have a low moisture content. The Maillard reaction, which is a reaction between proteins and sugars, is responsible for the transformation. This is a common reaction between reducing proteins in food. The Maillard reaction can be controlled in numerous ways. You can increase the rate of the reaction by altering the amount of sugar and proteins used. Temperature and time are the other regulating factors. The reaction is more faster at higher temperatures, therefore it browns much faster. It cooks more slowly at lower temperatures, allowing you to thoroughly fry the inside, like you would when making French fries. So in this presentation, we will observe how each pH solution affects the browning time of a potato. Which of these three do you think will brown a potato in the shortest amount of time? Let's find out.
The purpose of the science of cooking in regards to the Maillard reaction in action is to explain why potato food turns brown when it begins to cook. The Maillard reaction is a chemical interaction between amino acid and reducing sugars. Brown food has a particular flavor and the potatoes are no exemption. It also to know the single carbohydrate produce the greatest level of browning, implying that in a chemical process, the combination of glucose and solution produce the most browning. The next step is to distinguish between the solution, which include dipping in water, acetic acid buffer, and bicarbonate buffer. Therefore, by testing with potato food, you develop hypothesis, prediction, and explanation for each of the tests in the laboratory activity to learn about the Maillard reaction and how it influences the color and flavor of foods.
Procedure. Slice the potatoes into 1-inch pieces. Warm for about 3 minutes and evenly coated with 4 tablespoons of oil. Sear regularly the potatoes.
A few minutes later.
This is the time where the majority of pieces of potato are brown. Warm the pan for about 3 minutes and evenly coat it with 4 tablespoons of oil. several potatoes into the distilled water and cook it in the pan. Wait until the majority of pieces of potato are brown. Stir it regularly.
A few minutes later.
So we have here the time where the majority of pieces of potato are brown. This is the cooked distilled water dipped potato. We clean the pan after using it. Warm the pan for about 3 minutes and evenly coated with 4 tablespoons of oil. Dip several potatoes into the acetic acid. And cook it. Stir it regularly until it becomes brown.
A few minutes later.
It is the time where the majority of pieces of potatoes are cooked. We have here the potato where we dip in acetic acid and distilled water. See the difference between the two. After cleaning the pan, we warm it for about 3 minutes and evenly coated with 4 tablespoons of oil. Here the sodium bicarbonate solution and we dip several potatoes on it. And we cook it on the pan. We stir it regularly until it becomes brown.
A few minutes later.
So we have here the time where majority of the potatoes pieces are cooked. So we have here the potato. Look at that difference. So we have here the table. The browning time of potato is 6 minutes and 56 seconds, and the table 2 shows that the browning time of foods in different pH solutions. So we have here the potato, which is the food, and in different pH solution we have distilled water 6 minutes and 56 seconds, in acetic acid 4 minutes and 45 seconds, and in bicarbonate vapor we have 3 minutes and 4 seconds.
Number 1. Which single carbohydrate gives the greatest level of browning? When a potato or a vegetable will expose to heat, one of the many changes will take place, in which it will change in color and it will soften. Potatoes themselves are relatively high in carbs and they are also chock full of starch, which is a carbohydrate. Potatoes will turn to brown, or it has a broad category of changes when exposed to high temperatures because of pyrolysis. It is the heating of an organic material, such as biomass in the absence of oxygen. Potatoes are one of the most versatile foods out there and has the greatest level of browning due to the fact that the energy that the heat brings initiates transformations and reactions within the potato.
Number 2. Which of combination of carbohydrates and solutions gave the greatest level of browning? Based on our observations, the combinations of carbohydrates and solutions that gave the greatest level of browning is when the potatoes dip in acetic acid before frying. Due to the fact that among the 3 solutions, acetic acid is not that time-consuming in frying the potatoes, and it will get brown quickly. Browning time of potatoes when it is combined with acetic acid is 2 minutes and 45 seconds, while with distilled water it will take 4 minutes and 45 seconds. On the other hand, when potatoes combined with bicarbonate buffet, it will consume 3 minutes and 39 seconds. Number 3.
How did the level of browning for the carbohydrates compare to the results after dipping in water, acetic acid buffer or bicarbonate buffer? When we use a single carbohydrate in frying, it will take time rather than using or combining it with solutions because it will get brown quickly. Without using the combination of a carbohydrate and solution, the span time in browning a potato is 6 minutes and 56 seconds. Therefore, using a solution per carbohydrate will make it easily get browned, and cook also using a single carbohydrate in frying is time consuming.
Number 4. What was the main difference between these three solutions? The main difference between the three solutions is that if your potatoes are still wet or dip it with water before frying, when you fry or roast them, they are more likely to turn out limp and soggy. Soaking the potatoes does something magical with starches in which water within the potatoes evaporates, slightly drying out the potato. Acetic acid pretreatment improves the hardness of cooked potato slices. Acetic acid pretreatment keeps the wall structure of the cooked potato slices more intact. The changes of galacturonic acid levels were observed with the changes of the thermally cooked texture. Acetic acid pretreatment changes the monosaccharide content and the molar mass of the HF extracted from potato slices. Bicarbonate buffer breaks down the pectin in the potato and draws starch to the surface. Potatoes are full of both water and starch, and will gain the water when immersed in watery solutions. Conversely, they will lose water when in concentrated solutions such as those containing a great deal of starch.
How did the browning times compare for the different food items in each of the three solutions? During the browning of potatoes, in a distilled water, the potato was brown in a long period of time. In an acetic solution, the potatoes are being brown in a short time. Lastly, with the bicarbonate solution, the potatoes was brown in median time, and the color is the most brown than the two. For each of the different food items, which solution gave the fastest browning time? Which gave the slowest browning time? The acetic solution gave the fastest browning time, while the distilled water solution gave the slowest browning time. Using your data, how does changing pH impact browning times for the different food items? In general, maximum browning occurs at between 0.60 and 0.85, and the browning rate increases with increasing pH up to a pH of around 10. Maillard reaction is one of the most important reactions which result from food processing. Did the patterns of browning for the carbohydrates alone match the patterns of foods dipped in carbohydrate solution? Yes, browning occurs in varied levels depending on the amino acid. A higher water activity environment hinders the Maillard reaction because it produces water.
Conclusion. Number 1. Did your data support or falsify your hypothesis? So, if we fry the potato and put a different kinds of chemicals such as acetic acid, sodium bicarbonate, and distilled water, therefore, the potato will cook in a different time with a different texture, appearance, and color. So as a result, we predicted that this experiment and our findings back up our prediction. So the oil is also heated enough for the Maillard process to occur and the potatoes to brown attractively, and it can provide a crispy exterior with a wet interior. Number 2, how did you come to this conclusion? So as we watched the video laboratory presentation and designs of cooking potatoes, we came to the conclusion that adding various chemicals before frying the potato can make it easier to cook while also changing the appearance, texture, and color of the potato. We also came to the conclusion that one of the most difficult aspects of initiating the Maillard process is getting the surface hot and dry enough without overcooking the underlying flesh, or at least as little as possible. So number 3, did the results change your thinking about this topic? How? Yes, the result change our thinking about this topic. So the findings alter our perspective on the subject as heating foods provides various food safety benefits. So the Maillard reaction products are generated during the heat process. Color, taste, and texture are all sensory elements of food that MRPS contribute. Number 4, what changes would you make to your hypothesis based on this new data? So the chemical reaction did not occur automatically when a potato is heated. Various chemical reaction occur during storage. It's common knowledge that keeping a potato in the fridge causes starches to break down into sugars, and using chemicals on potatoes before frying will result in a different texture and color of potatoes in this experiment. Okay, number 5. What changes would you make to the experiment to better clarify your result? So, when you cook a potato, no matter what method, whether it's boiling, frying, baking, or steaming, your potato will visually change. It turns from a hard tuber into a softer crumbler and products that easier to mash, bite, chew, cut, and chew. So, the goal of this experiment is to investigate on putting an acetic acid, sodium bicarbonate, and distilled water to the potatoes before frying it. As with potato, a lot of different processes happens simultaneously at high enough temperatures. Sugars and proteins in the potato will react in the Maillard reaction. So this makes a potato turn brown and get a lot of delicious flavors. So a high temperature cooking speeds up the Maillard reaction because heat both increases the rate of chemical reaction. So as the food dries, the concentration of reactant compounds increases and the temperature climbs more rapidly. And also the temperatures need to be high to bring about the Maillard reaction, but as long as the food is very wet, its temperature won't climb above the boiling point of water. So the atmospheric pressure, only high heat cooking techniques can dry out the food enough to raise the temperature.